Lewis. So there are given chemical equations there. You will identify if which the given reactants could be acid or could be base, and what's the basis of your claim. So you can apply the definitions given by Arrhenius, Bronsted, Lowry, or Lewis. Okay, so recall that one. And then the different chemical reactions that involves acids and bases. So I gave you like 8 chemical reactions. There are given reactants, so you will predict the product and balance the equation. And then some properties of acids and bases. Okay. And then the different chemical calculations on acids and bases, such as the number of replaceable ion, equivalent mass, number of equivalents, molarity or concentration, and normality. Okay, they're the one you watched in the lecture video last week. Okay, so I do hope you take down notes of that lecture. Okay. Anyway, we are still to continue that today. And then for the physics, so we have the particle and wave natures of light, the electromagnetic waves, as our light is a part of, and then the parts of waves, okay, in a wave train, and then how to calculate for the frequency, wavelength, and energy carried by light, and then also the dispersion of light, including color addition and subtraction, and then some applications of the colors of light, and then loss of reflection, both concept and the calculations. So the calculations we are still to discuss tomorrow during physics class. Okay, so those are the pointers in chemistry and physics. So later I will send you a copy of this. Okay. All right, so for today, we just continue with the discussion on the lecture video you watched last week, which has something to do with normality. So as defined in our lecture, normality is the number of equivalents of a given substance per volume of the solution formed by the substance in liters. Okay, so that's how we define normality. Now let us have some other examples of calculations for normality. So remember the chemical equation for normality, or the formula for normality, which is N equals number of equivalents of solute divided by the volume of the solution in liters. So this is the working equation that we will use, okay, for normality. Now let us have this example. So first, let's say we are asked to calculate the normality of a 600 ml solution made by dissolving letter A 100 grams of hydrochloric acid, B 50 grams of ammonium sulfate, and C 30 grams of sodium hydroxide. So in here we are given the volume of the solution made by the following solutes. Okay, and the volume is 600 ml. Are we using this volume in our calculation? Okay, are we using 600 ml in our calculation? Yes or no? And if not, what should we use as volume?
Change to liter.
Change to liter. Okay, yes, that's correct, Jaya. And what should be your volume in liter?
0.6.
0.6 liter. Okay. Next, for letter A, we are given 100 grams of hydrochloric acid. So let's determine first the relative mass of hydrochloric acid, or HCl. So for hydrogen, we have 1 plus chlorine is 35. So we have 36 grams per mole. After that, what do we get? Determine the number of replaceable ion of hydrochloric acid. So what's the number of replaceable ion of hydrochloric acid?
1.
Okay, 1 equivalent per mole. After number of replaceable ion, we get the equivalent mass. And equivalent mass is the number of the relative mass, which is 36 grams per mole, divided by the the number of replaceable ion, and it is still 36.
36
Yeah, it's still 36. But the unit will be
grams per EQ.
okay. So 36 grams per equivalent. Next, we can now calculate for the number of equivalent, and that is equal to we divide the mass. What's the mass of hydrochloric acid? 100 grams. So we divide the mass of hydrochloric acid by the equivalent mass. And what will be the result?
2.7
2.7 what?
equivalent.
Mm, it should be how many significant numbers?
3.
4, I think.
4. So 2 point.
2.778.
Okay, yes. Equivalent. Next, so we have 2.778 equivalents. We are now ready to calculate for normality using this working equation. So for the normality, we divide the number of equivalents, which is 2.778 equivalents, by the volume of the solution made in liters, and that is 0.6. So what's the result? Normality is equal to
4.63.
I'm sorry, what's the result?
4.630.
4 point. Okay, yes. Unit equivalent per liter.
Normal.
What?
Normal.
Normal. The symbol of normal is still N. Okay, so that's for letter A. Now let's do letter B. So for letter B, the given substance that we have are, so I'll just, anyway, we are just doing the same mechanics of calculations. Okay, so what is the given substance in letter B? Okay,
50.0 grams of ammonium.
so yes, 50 grams of ammonium sulfate. What's the symbol of ammonium sulfate?
NH4S.
NH4S. NH4. Is it like that? NH4S.
Uh,
Okay. SO4. Are we done? And just
I think
NH4.
NH4 2.
Okay.
R2SO4.
Yes, NH42SO4 because sulfate has a net charge of -2. Okay, so that is equal to nitrogen is what atomic mass?
14.
14
14.
multiplied by
14 multiplied by 2.
2, and then plus hydrogen is 1 times 4 times 2
8.
8.
is 8 plus sulfur is
Sulfur 32.
32
2.
plus
Uh,
oxygen is
16 times 4.
16 times 4.
okay.
132.
So yes, the mass is
32.
132. Okay, grams
Grams per
per
mole.
mole. All right, next. How many equivalents per mole or replaceable ion is ammonium sulfate?
2.
2. Yes, that is correct. Next, let's substitute. The equivalent mass is the relative mass, which is 132 grams per mole, divided by number of replaceable ion, which is 2. And what's the result?
66.
66. So we have 66 grams per mole. Next, get the mass of ammonium sulfate, 50 grams. Okay, and then we divide 50 grams by the uh, equivalent is 66. So what is 50 divided by 66?
0.758.
0.758. Did you get the same result? So 0.578 equivalent.
Yeah. So yeah.
Okay. Next, we substitute our value. So we have 0.758 equivalents divided by the volume of the made solution in liters, and that is this one, point still point 6. So what's the result?
1.263.
How many significant numbers?
3.
So how do you express your result?
1.26.
Okay, 1.26 normal. Okay, so that's our answer in B. Okay, and finally we have letter C. So let's just use the same mechanics of solution. So what's the substance in C?
Sodium hydroxide.
Sodium hydroxide. Okay, and we are asked to find the normality. Okay, how many grams of sodium hydroxide is given?
30 grams.
30 grams. Okay, yes. Okay, so let's do it. So in letter C, we have sodium hydroxide. And what's the chemical symbol?
NaOH.
Uh,
And
oxide. So yes, it's NaOH. All right. Sodium is what atomic mass?
23.
23. Yeah.
Okay.
Plus
Plus
16 this one.
16.
oxygen 16 plus
1.
hydrogen 1. So
40 grams per mole.
40 grams per mole. Okay. How many equal ion sodium hydroxide have?
1.
1. Next, divide relative mass, which is 40, and equivalent mass, which is 1. So the result is still 40. 40 grams per equivalent. Next, divide the given mass of sodium hydroxide, which is 30 grams. So divide it by the equivalent mass, which is 40. And what's the result?
0.75.
0.7, 0.75, 750 equivalent. Okay, next. We substitute that here. So the number of equivalents is 0.750 divided by zero point 0.6. And what's now the normality?
0.125 normal.
Did you get the same? 0 point what?
Normal.
Yes, it should be 1.25 normal. Okay? So let's have our last example. The formula of all of those calculations, you're again able to do them correctly. Okay, so let's have the last example. So let's say we are asked to so we are asked of this, so what is the normality of a 0.120 molar aqueous solution of phosphoric acid? So here you are given the concentration of the solute in phosphoric acid, and the concentration is in terms of molarity, so that is equal to 0.120 molar. Okay, and then okay, sorry guys, I suddenly lost connection. All right, let's go back to our lecture. All right. So aside from the concentration, what else do we need to calculate the normality? We also need the,
Number of replaceable ion.
yes, the number of replaceable ion of the substance phosphoric acid. What's the symbol of phosphoric acid, by the way?
Uh,
H3PO4.
Okay, yes. Now, what is the number of replaceable ion of H3PO4?
3.
3.
3.
2.
Okay, 3 equivalents per mole. Okay, so to calculate for the normality, what do we do? Okay, we simply multiply,
Molarity with number of replaceable ion.
okay, molarity or the concentration times the replaceable ion. Okay, then it will be equal to, okay, molarity is 0.120. Molar is also equivalent to mole per liter. Okay, multiplied by um, the number of replaceable ion of 3 equivalents per mole. So in here we can cancel mole. So if we cancel mole, the remain, okay, so multiply first 0.12 and 3. What will be the result?
0.360.
0.360. Okay, and
Normal.
then it will be equivalent per liter. And what is equivalent per liter equal to?
And normal.
Okay, it's equal to N or normal. Okay, and that's how we get the normal in terms of the given concentration. Okay, so tomorrow, I mean Friday, so spend the time to review for the chemistry and then prepare for your tests by Friday. Okay, so that's all. Enjoy the rest of the day. Goodbye, class.
Goodbye.
Goodbye and thank you,
Goodbye and
Teacher
thank you,
George.
teacher.
Bye, thank you, teacher.